Hi children, good morning. In the previous video, we learned some important theorems. If a transverse, let's say, two parallel lines, the formed alternate interior angles are equal. These are alternate exterior. Alternate interior means these. In the earlier video, we learned this one. In the previous video, alternate exterior angle theorem, co-exterior angle theorem, an angular bisector theorem, angular bisectors of corresponding angular bisectors of alternate interior and angular bisectors of co-interior angles. Angular bisectors of co-interior angles. These things we learn in yesterday's video. Here, these two lines are parallel. Angular bisectors of alternate interior angles are also parallel if the lines are parallel. Okay, here angular bisectors of corresponding angles are also parallel. Here angular bisectors of co-interior angles are perpendicular to each other. They meet at 90 degrees. These theorems we learned in yesterday's video. Now, in this video, we have to learn some important results. Important results based on parallel lines. First one, two lines are parallel to the same line are also parallel. Two lines are parallel to the same line are also parallel. Observe here. Here L, M, N are three lines. Here what is given? L is parallel to M and N is parallel to M. Two lines are parallel to the same line. Here L is parallel to M and N is also parallel to M only. Here two lines are given which are parallel to the same line M. Now we need to prove L is parallel to N. Okay, here L is parallel to M, N is parallel to M, we need to prove these two lines are also parallel. Two lines are parallel to the same line are also parallel, we need to prove. Here, construction will. Till now, we did many problems based on transversal. That's why construct a transversal. Construct a transversal. T, which meets L, M, N at A, B and C respectively. P is a transversal, meets at A, at B, at C. We have three angles A, B and C. Small a, small b and small c. Proof. Now L is parallel to M and T is a transversal. With this one you can say angle A equal to angle B, corresponding angles. Corresponding angles. Now, M is parallel to M and P is a transversal. Now, angle C equal to angle B. Second, here also same. Corresponding angles. Corresponding angles. From 1 and 2, we can say angle A equal to angle C. Can we say or not? Yes. Two things are equal to the same thing. Okay, A equal to B and B equal to C they give. So A equal to C. Now, what are A and C? For L and N, A and C are corresponding angles. Now we got corresponding angles are equal. That implies lines are parallel. Lines are parallel. Hence two. Two lines are parallel to the same line are also parallel. We need to prove. Here, what are the two lines we have? L and N are parallel to M, middle one. We need to prove L is parallel to M. Those lines are also parallel. Construct a transversal which meets L and N at A and B, C respectively. Here small a, small b, small c are three angles are formed. Here L is parallel to M and D is a transversal. With the help of those two lines, we have A and B. With the help of these two lines, we have C and B. A is equal to B and C is also equal to B. Two things are equal to the same thing are also equal. Now A equal to C. Here A equal to C and it is a transversal which means L and N at two distinct points. So if the formed corresponding angles are equal, lines are parallel according to the converse of corresponding angles axiom. Okay, with the help of the theorem we can say these two are equal. Next. Another theorem. Now, two lines are perpendicular perpendicular to the same line. What are perpendicular lines? Two lines are perpendicular to the same line are also parallel. Two lines are parallel to the same line are parallel. Two lines are perpendicular to the same line are also parallel only. What are perpendicular line mean? Here L and M are perpendicular because they meet at 90 degrees. Two lines intersected at 90 degrees, they are treated as perpendicular to each other. L is perpendicular to M and M is also perpendicular to L. Perpendicular to each other. Perpendicular to each other. So, here two lines are perpendicular to the same line. Now, P is perpendicular to R and Q also perpendicular to R. We need to prove P is parallel to Q. First one, hypothesis. P is perpendicular to R and Q is perpendicular to R. We need to prove P is parallel to Q. Construction, no need. Here perpendicular line itself with the transversal, that's why no need of construction. Proof. Here this one A, this one B. Now angle A equal to 90 degrees. Since P is perpendicular to R degree. This is the symbol of perpendicular. Perpendicular symbol. Perpendicular. So angle A is also equal to 90 degrees since Q is perpendicular to R. Q is perpendicular to R. Okay, A equal to 90, B equal to 90. Therefore, A equal to B. If here A and B are corresponding angles. The corresponding angles are equal. Then the lines are parallel. But two lines are perpendicular to the same line. P is perpendicular to R and Q is perpendicular to R. Then P is parallel to Q. We need to prove. That is hypothesis and conclusions are even known. Here the construction doesn't require. Proof angle A equal to 90 degrees because they are perpendicular lines. Angle B equal to 90 degrees, they are perpendicular lines. So both are equal to 90, that's why A equal to B. If A and B are equal, the lines are parallel because A and B are corresponding angles. The corresponding angles are equal, the given lines are parallel according to the converse of corresponding angles axiom. Next theorem. If the arms of body, if the arms of two angles are parallel to each other, then the given angles are either equal or supplement. If the arms of two angles are parallel to each other, arms of two angles are parallel to each other, then the given angles either equal or supplementary. In case 1, equal case I am taking. Here A, B, C. Here P, Q, R. These are the symbols for parallel lines. Here AB parallel to PQ and BC parallel to QR. Arms of two angles are parallel to each other there. Arms of two angles are parallel to each other they gave. So here AB and BC are arms of angle ABC. PQ and QR are the angles of arms of angle PQR. Let angle ABC be X, angle PQR be Y, that is Z. Okay, conclusion, we need to prove X equal to Y. X equal to Y. For proving X equal to Y, first condition, AB parallel to PQ and for this one, AB parallel to PQ and BC is a transversal. BC is a transversal. Okay, AB parallel to PQ and BC is a transversal. Therefore, X equal to Z. Here X and Z are corresponding angles. Corresponding angles. Another one. BC parallel to QR. BC parallel to QR and PQ is a transversal. PQ is a transversal. Now Z equal to Y. Second statement, again corresponding angles. Corresponding angles. First one, AB parallel to PQ and BC is a transversal, so X equal to Z corresponding angles. BC parallel to QR and PQ is a transversal, so Z equal to Y. Here also corresponding angles. From 1 and 2, X equal to Z and Z equal to Y. That implies X equal to Y. X equal to Y. Here in this way also we can use. Here A, B, C. This one P. This one Q. Here R. In this way also we can do. Here angle ABC X and angle PQR Y. X equal to Y. There also case 1 only, that one also. Arms of two angles are parallel to each other. Here these two arms are parallel, these two arms are parallel. In this case AB and PQ, here BC and QR. In this case AB and PQ, here also BC and QR are parallel. In that way also we can draw. Both figures are showing the same picture. Okay, this is case 1 only. What is the case 1? If the arms of two angles are parallel to each other, then the given angles are equal with load. And second case we have, what is the second case? They are supplementary. Okay, at which aspect they are supplementary? Now we need to prove. Second case. See the first case. AB, PQ, XZ, BC, QR, Z, Y. X equal to Z and Y equal to Z. So X and Y are equal. In this case, both angles are equal. Here also both angles are equal. First case. Now coming to second case. Second case, they are supplementary. We need to prove. A, B, C, P, Q, R, X, Y. This one here, AB parallel to QR, BC parallel to PQ. Hypothesis here AB parallel to QR and QB parallel to BC. Right. Conclusion. Now we need to prove x plus y equal to 180 degrees. In this case, they are supplementary. We need to prove. Anywhere arms only. There also arms. Here also arms. In two cases, we can prove this one. The first one, equal. Equal case we discussed. Now supplementary case we are discussing. Both are arms of angles and parallel to each other. Now, proof. First one, AB parallel to QR. AB parallel to QR and BC is a transverse. And BC is a transversal. AB parallel to QR and BC is a transversal. Here x equal to z. First case, corresponding angles. Lines are parallel, the form corresponding angles are. Second, QB parallel to BC and here QB parallel to BC and QR is a transversal. QR is a transversal. In this case, y plus z equal to 180. This is second case. Since y and z are co-interior angles. Co-interior angles. They are co-interior angles. Now, if the arms of two angles are parallel to each other. Arms of two angles are parallel to each other. In first case, they are equal with load. We need to prove either equal or supplementary. In one case, they are equal. In another case, they are supplementary. Now we are doing supplementary case. Here, AB and QR parallel lines and BC is a transverse x equal to z corresponding angles. Now QB parallel to BC and QR is a transversal. Now y plus z equal to 180 degrees because y and z are co-interior angles. If the lines are parallel, the formed co-interior angles are supplementary. Formed co-interior angles are supplementary. So y plus z equal to 180. Here z replaced by x. Then y plus x equal to 180. That means x plus y equal to 180. Hence true. Remember? This is proved in this way. The arms of angles are parallel to each other. Then the given angles either equal or supplementary. In equal case only include, now supplementary case with the help of co-integral angles. Here y and z are co-integral angles and x equal to z. Z replaced by x means x plus y equal to 180 degrees. In this way you can prove this result. After the completion of important results, the first result is two lines are parallel to the same line, are also parallel, and the second result, two lines are perpendicular to the same line are also parallel. And the third one, arms of two angles are parallel to each other, either equal or supplementary. Either equal or supplementary. After completion of these three results, first one, now important properties. Important properties. Important properties. First property, reflexive property. Reflexive. Every line is parallel to itself. Parallel to itself. L is parallel to L, M is parallel to M, X is parallel to X, like this. Every line is parallel to itself is called a reflexive property. Mean a reflexive property with respect to the parallel lines is true. Reflexive property with respect to the perpendicular lines. Every line which is not perpendicular to itself, that's why it is false. Next, symmetric property. Symmetric property. Two lines are always parallel to each other. L and M. Meaning L is parallel to M and M is parallel to M. Two lines are always parallel to each other. This is reflexive, symmetric. Next, transitive property. Transitive. Two lines are parallel to each other. Parallel to the same. Parallel to the same line. Are also parallel. Are also parallel. Already we proved this one. L is parallel to M, M is parallel to N, L is parallel to N. Two lines are parallel to the same line are also parallel. Two lines are parallel to the same line are also parallel. This is a transitive property. The first one is reflexive. Every line is parallel to itself. Reflexive is true for parallel lines. Reflexive is false for perpendicular lines. Every line which is not perpendicular to itself. Next, symmetric. Two lines are always parallel to each other. Two lines are always parallel to each other. Meaning L is parallel to M as well as M is also parallel to L. Two lines are parallel to each other. Two lines are perpendicular to each other. That is true for perpendicular lines also. Symmetric property. Next, transitive property. Two lines are parallel to the same line are also parallel. Already we proved in the first result. That is, L is parallel to M, M is parallel to N. Then automatically L is parallel to N. This is not true for perpendicular lines. Okay, this is not true for perpendicular lines. Because the two lines are perpendicular to each other. Perpendicular to the same line are parallel lines. Okay, here L is perpendicular to M, M is perpendicular to M, then L and N are parallel lines only. If they are perpendicular, transitive true. Okay, this property observe for numbers. Reflexive means every number equal to itself. A equal to A, B equal to B, C mean 1 equal to 1, 2 equal to 2, 3 equal to 3, like that. Equality holds true reflexive property. Inequality doesn't hold because 1 is less than 1, correct? No. Every number is not less than itself. Every number not greater than itself. Every number 1 is not equal to 1. That is false. For inequality, reflexive doesn't satisfy. Next, symmetric property means if A equal to B means B is also equal to A. A equal to B means B is also equal to A. So symmetric is true for the numbers. Mean here transitive means A equal to B, B equal to C, then automatically A equal to C. This is transitive property. Transmission. Transitive property. Transitive property. Okay, reflexive, symmetric, transitive properties. For parallel lines and perpendicular lines we proved. Numbers for checking only I said. Okay, every line is parallel to itself is reflexive. Two lines are always parallel to each other, that is symmetric. Two lines are parallel to the same line are also parallel, that is transitive. Okay, these three properties are satisfied by parallel lines. For perpendicular only symmetric is true. Two lines are perpendicular to the same line are also parallel. If they are perpendicular, that one also true, but they are parallel. So symmetric L perpendicular to M means M is also perpendicular to M. Okay, here, see here, consider these two lines L and M. Now L is perpendicular to M. M is also perpendicular to L. So in this way we can prove these results. Okay, these are important results. And in this video we discussed three important results and important properties we discussed. In the next video we will discuss problems based on these. Transversals, alternate interior, alternate exterior, co-interior, co-exterior. These problems we will discuss. Have a nice day.